and display equipment using cards and tape.
Here on the platform, we have a computer terminal and some display equipment. We wish to show how this equipment can be used to design an aeronautical structure. Consider a supersonic aircraft such as this shown in our first poster. We wish to design this portion of the fuselage shaded in red. From a structural point of view, we will be designing a stiffened cylinder. During the flight of the aircraft, this cylinder is subjected to several combinations of bending and internal pressure loadings. The next poster is a sketch of altitude versus time for the aircraft. The design conditions occur during taxi, gust, maneuver, and landing. We would like to design a stiffened cylinder which has minimum weight, but will not buckle or yield when subjected to any of the given flight loads. We would also like to see visual displays of the cylinder during the design. We start the problem by supplying the computer with a preliminary trial design. A recently developed computer program will then modify this design to obtain the minimum weight design. The design variables being modified are the skin thickness and the thickness, depth, and spacing of both circumferential and longitudinal stiffeners. The initial design is now printed here and displayed on the cathode ray tube. Here we have three drawings. The cylinder with circumferential and longitudinal stiffeners. For clarity, only every third stiffener is shown. A detail of the cylinder skin and longitudinal stiffeners, and a plot which shows how the weight per unit area changes with each stage in the redesign. The weight per unit area of the initial design is approximately 5.7 pounds per square foot. At certain stages in the optimization of this cylinder, we can display intermediate results. The design variables for the first stage in the redesign are printed here and displayed on the cathode ray tube. You can see that the new design has decreased in weight. We now continue the process of obtaining printouts and displays of successive stages in the redesign. The weight per unit area has now leveled off to approximately 1.7 pounds per square foot, and additional redesigns are not useful. I will now make a copy of the final design. For comparison, we shall review the initial design. The final design is appreciably different from the initial one. It weighs less than 1/3 the initial design, and its stiffeners are thin and close together. In summary, we have given you a demonstration of computer-aided structural design. In this case, we designed a stiffened cylinder representing a portion of an aircraft fuselage. Computers can play an important role in the design of other types of structures, from the frames for buildings to minimum weight isotropic shells of revolution.